Hello and Assalamualaikum to Miss Natasha. My name is Akila Izzati with the matrix number of 207558, and my friend Wanul Bakis Falihah will be presenting about food irradiation. First and foremost, we need to know what is the definition of food irradiation. Food irradiation is a chemical process that exposes food to ionizing radiation such as gamma rays, electron beam, and X-ray without having any physical contact with the food product itself. This action could kill insects, mold, and microorganisms, thus resulting in extending shelf life and reduces storage of food. I will be explaining about the mechanisms of gamma rays in food preservation. The most common source of ionizing energy is cobalt-60. This radioactive material is contained in two sealed stainless steel tubes called source pencils. These are placed in a rack, and the entire rack is immersed in a water chamber underground when not in use. When irradiation takes place, the rack is raised. Packaged food products move along the conveyor belt and enter an inner room where they are exposed to the rack of containing source pencils. Energy in the form of gamma rays, or can also be called as photons, pass through the encapsulation and treat the food. It also breaks the chemical bonds of food, similar with other food preservations. Unfortunately, a small number of molecules are left and safe to be consumed. The FDA has evaluated the safety of irradiated food for more than 30 years and has found the process to be safe. Gamma rays are measured in units called rads, and you should know different food composition requires different amount of gamma rays needed. Lastly, water, which has the property of non-reactive compound, will be used to shield cobalt-60 when they are not in use. As you can see in the slide, this is the example of food irradiation machine that commonly used in food industry. As soon as the gamma rays penetrates the food product, which is the strawberry, the bacteria and microorganism inside the food dies. Next, is there any nutrient changes in irradiated food? Research has been found that low doses irradiation does not have any effect on foods. It should be safely consumed by human. However, high dose of radiation can cause a slight change in the food nutrition. Food components are divided into two, which are micronutrient and macronutrient. Both of these food components were affected differently based on their factors that plays a significant role in changing the food nutritional composition. The first one is radiation dose. As we all know, low doses do not really change the nutrient of the food, but high doses does. So it depends on type of food, whether what kind of doses would be better in the food preservation. Same goes to the constituent of the irradiated food. Next, type of packaging. Each food product requires a specialized packaging based on their food properties. As an example, nuts are usually packed using vacuum to remove air particles that could trap in the packaging. So it usually needs different doses of radiation. Lastly, temperature and oxygen saturation also could chemically affect the nutritional composition. I'm passing the presentation to the next presenter, Balkis.
Okay, thank you, Akila, for passing the mic. My name is Wanul Bakis with the metric number of 208179. And now I'm going to talk about the electron beam accelerator, in which one of the ways to radiate food for preservation other than the gamma rays. What is electron beam accelerator or electron beam irradiation? It is a novel, non-thermal and physical methods of food preservation technology, and as Akila mentioned before, food radiation in all sort of any wave aims to kill insects or any pathogens microorganisms to extend a product's shelf life, in which for electron beam irradiation, it is applicable to package or sealed products while being safe and effective, which does not cause any radiation towards humans. Next. So as you can see here, this is the schematic diagram of electron beam accelerator that is used for food irradiation. Next. Now moving on, the focus is on the extended sites after the scan horn. For A, it is X radiation or X-ray as shown on diagram above, as it radiates different wave after the electron beam approach the target. while at B, it is known as electron beam or E-beam, as it will directly approach the food products from the electron beam accelerator machine. Next, for E-beam, it is on high speed of velocity but is low in capacity on its releases, in which resulting in short treatment of time with high dose rate thanks to the velocity. Mm, the food products will absorb the electrons energy and damaging the DNA of the pathogens in the cell, thus destroying the abilities or capabilities of the microorganisms to reproduce and will halt all activities of microorganisms before it spoils the food. Next. On the closer look for X-ray, as I mentioned before, the electron from E-beam is converted after it reach a target of shield in which we usually use the tantalum shields, as the wave can penetrate the block of substances in which tantalum substances really well. This wave can penetrate the products way deeper than an ultra E-beam that resulting in high depth penetration with a good dose of it on a uniform ratio. However, even though the penetration exceeds the normal E-beam, it is less effective as the X-ray wave is not strong enough after colliding its particles with the tantalum shield. In short, food radiation is a form of food safety to ensure a higher quality of food product for us as consumers. However, do remember that this technology is still on limited applications as it is relatively still considered as expensive in the industry while being effective on normal microorganism pathogens and not viruses. That's all from us, Akila and Balkis. Thank you for listening and have a good day.